Hello, my name is Vicky Stone. Welcome to this podcast, which is on the Gracious Framework, which is an EU project looking at grouping and read across for nanomaterials. So this presentation is going to give you an introduction to the Gracious project and why it's important. We'll look at the structure of the framework that the Gracious project has generated, and then we'll investigate how current and future involvement of stakeholders might contribute to the testing of the framework and its further development. So Gracious, as I said, is a European Horizon 2020 project. Its aim is to generate a framework to enable practical application of grouping and subsequent read across of nanomaterials or nanoforms. The idea is that this aim should align with the needs of EU legislation and the needs of industry. This is a 3.5-year project which started in January 2018. If we think about conventional approaches for risk assessment, these consider each substance on a case-by-case basis. To do this, they require information on the physicochemical characteristics of that substance, exposure to the substance, and any hazard information relevant to that substance. The hazard information can be gathered via testing, but can also be gathered via grouping and read across approaches, or in some instances it can be waived. The information for this case-by-case assessment can come from existing data, for example, the published literature, or it could be new data that's derived from a variety of testing and alternative sources. The problem is that each information source often has issues. There can be ethical issues with the animal models used in testing. There can be financial issues due to the costs of testing. Sometimes the data that's generated or available, there are questions about its applicability for risk assessment. And of course, there's the time taken to conduct all of the activities required for a case-by-case assessment. And this is why alternative approaches such as grouping have been proposed. So grouping is a way of streamlining information gathering for risk assessment. It's mentioned in REACH Annex number 11, where it states that substances whose physicochemical, toxicological and ecotoxicological properties are likely to be similar or follow a regular pattern as a result of structural similarity may be considered as a group. So essentially, similar substances could be grouped together. Once you've conducted a grouping of these similar substances, you can use that group to support or apply read across. So read across is when you have a substance which has data available for a specific hazard endpoint, and you can read across that hazard information to a data pool or target material or substance for which you lack data. So this must be considered one endpoint at a time. It can only be done within a group, but it requires justification or an evidence base to support that read across decision. Within the REACH annexes, nanoforms have been now specifically mentioned. A substance registration dossier requires hazard and risk assessment information for nanoforms, and it's recognised that nanoforms may need different or additional testing and information compared to other forms of a substance. Within the REACH annexes, alternative methods are encouraged, and this includes grouping and read across. And there are guidelines for grouping and read across within these REACH annexes, which state that grouping and read across require consideration of physicochemical properties, toxicokinetics, and the hazard, both human and environmental hazard, of these nanoforms. Importantly, these annexes state that grouping should be hypothesis-driven, and so the Gracious framework is underpinned by generation of hypotheses that can be tested to support grouping and read across. So the Gracious framework has been based on existing information that occurs in the ECHA guidance, but also in other European and national projects. And we brought this together to make a draft framework, which we shared with a wide variety of stakeholders using a number of different platforms. And from this, we gained feedback, which we used to modify and update the framework, especially in relation to how the framework is presented, to make it more simple and clarify the different steps involved. We'd like to thank the variety of stakeholders that were involved in the engagement process. We have European and non-European stakeholders, industry, regulators, policymakers, non-governmental organisations, as well as consultants. And the feedback that we obtained was that the framework essentially had a suitable structure, but it was rather complicated for people to understand. And so today I'm going to present to you a simplified and a slightly more complex form of the framework so that you can see some of the detail. So the framework starts, or the entry point for the framework is a user who has either a single nanoform or a provisional group of nanoforms that they would like to consider for grouping. The framework stimulates that individual to provide some basic starting information. So this is step 1 of the framework. This basic starting information includes the purpose of grouping. So is it, for example, for a regulatory dossier generation, or is it to support safe by design approaches to innovation? We also need basic physicochemical characteristics of the nanoforms. This can be predicted information if measured values are not available, or it can be the known values. And we also require information on the use and potential exposure scenarios for that nanoform within a product. And again, this can be predicted or it can be known information. Once you've completed the basic starting information in step 1 of the framework, step 2 identifies a hypothesis that is relevant for your nanoform and the use or exposure scenario in which that nanoform is being applied. The framework is populated with a large variety of different hypotheses which the experts within the Gracious Consortium have constructed through knowledge of the published literature. And so the basic information will be used to screen and identify the most relevant hypotheses that explain how your nanoforms can be grouped together based on a specific hazard endpoint. If one of these predefined hypotheses are not relevant, the framework also includes a template that allows the user to make their own user-defined hypothesis. So once we have a predefined hypothesis or a user-defined hypothesis, the framework then provides a tailored testing strategy with 3 tiers of increasing complexity that allow the individual to test the relevance of their hypothesis for the grouping of the nanoform or nanoforms they're interested in. And this tiered testing strategy allows you to gather evidence so that you can either make a decision to say that your group is justified, and if it's not justified, then you can refine your hypothesis, or the user can gather information for the individual nanoforms and do a case-by-case risk assessment. So this is the same diagram again, but this time in a slightly more detailed form. So we have the same entry point of a single nanoform or a provisional group of nanoforms. The basic starting information is the same again. We have the purpose of grouping, the phys-chem characteristics, and the release or exposure scenarios. And then we have the triggering of these predefined hypotheses within the framework that have been provided by the experts in the project. So once we have a screening of those hypotheses, you can see in this diagram that there are several examples of hypotheses available, and there's also room to add additional new hypotheses in the future, or there's the ability for an individual to make their own user-defined hypothesis. So these hypotheses are tested by integrated approaches to testing and assessment, or IATAs. These are the tailored testing strategies that I mentioned in the previous slide. And they use a combination of information from existing sources, from modelling and from testing, and they combine it together using a data matrix. And this data matrix gathers together all of the evidence that you need to assess whether your hypothesis can be accepted or rejected. The purpose for which you're grouping or doing the read across determines how many tiers of testing may be required, or tiers of information may be required within the IATAs, with something like an early stage of innovation just requiring the simple early tiers of 1, whereas a regulatory approach might require more tiers to be conducted. So again, once you have your information, you can then decide whether to accept your hypothesis so that you can group your substances together, or you reject your hypothesis, allowing refinement of that hypothesis or a risk assessment of the nanoform on a case-by-case basis. The read across within the Gracious framework follows the same pattern or the same logic. You start off with your target nanoform, which lacks data, and you generate a hypothesis for a grouping in which you think that nanoform might fit with source nanoforms providing data that's not available for the target nanoform. So you can take that available data for your source nanoform and potentially read it across to your target nanoform. So first of all, before you do this, you generate a read-across hypothesis that allows you to structure the endpoint and the ideas behind that read-across. Then you gather the information to support your read-across hypothesis, and then you assess whether you have enough information to accept or reject your hypothesis. As I've said, we're keen that the framework is used in a regulatory context, but that it's also used during the innovation of new products. And so we think this framework can support the safe by design approaches, which avoid expensive, time-consuming and unexpected problems with new nano-enabled products. And so by using grouping and read across, we hope you can streamline the innovation process. So the innovation process can be described by this stage gate process, where early gates go from discovery through to gate 5, where you launch a product on the market. You can see that the basic starting information step of the framework maps onto stages 1 to 4, whereas the second step, where you go through the tiered testing, can map onto stages 3, 4 and 5 of the framework, with stages 3 requiring, for example, just the early tiers of the framework, whereas stage 5 might require more of the tiers. As we were generating the hypothesis for the framework, it became apparent that we needed some way of controlling the content and formulating these hypotheses. And so we generated a template in order to make sure it was done in a structured manner. So this template describes along the top the purpose of the grouping, so whether it's for a precautionary approach, whether it's to guide targeted testing, whether it's for regulation, or whether it's for safe by design. And then it describes the context, so are you interested in an occupational exposure, a consumer exposure, or for the environment? Then in the yellow box, we input information about the life cycle of the nanoforms, so for example the physical form when being handled, the intended use of that nanoform, and potentially information about exposure dose as well. Then we have in blue, green and pink what they are, where they go and what they do. These are terms that are used in the REACH annexes. What they are corresponds to physicochemical identity. Where they go corresponds to environmental fate, uptake and toxicokinetics, and what they do refers to the hazard both to humans and the environment. So we've used this predefined hypothesis template to formulate the hypotheses that are used within the framework, and this same template can be used by stakeholders to make their own user-defined hypothesis. For the predefined hypothesis, these are defined on existing literature and available information. We have 2 general hypotheses, and we have 16 that are specific for human hazard. As of 2 weeks ago, we had 9 environmental hazard hypotheses, but we've now expanded these to 18. They span different exposure scenarios and exposure routes, and they encompass both fate and hazard in the environment. Here are just a few examples of the human hazard hypotheses, where I corresponds to inhalation, O corresponds to oral, and D corresponds to dermal. So you can see that each hypothesis is prefixed by the physicochemical characteristics of the nanomaterial. Then we have the route of exposure, and then we have the hazard impact. So, for example, the first one focuses on high aspect ratio nanomaterials. So these are fiber-like nanomaterials following inhalation and their impact on lung toxicity. The second one corresponds to quickly dissolving nanoforms that after inhalation might induce toxicity that's associated with their ionic or molecular forms. For the third one, we have very slowly dissolving nanoforms, often known as poor solubility nanomaterials, following ingestion and how they might interact with the gastrointestinal tract wall, leading to translocation. And then for the final one, this is a dermal application for larger nanoforms, with a suggestion that larger nanoforms are unlikely to penetrate the skin. For the environmental hazard hypotheses, this wording has been updated since the version that I'm showing you here, but again it includes information about the physicochemical characteristics, the compartment of the environment, and the hazard associated with exposure to that compartment. So you can see we have hypotheses that look at dissolution of nanoforms. We have ones that look at the coating and the stability of the coating in different environments, and we also consider the stability of different dispersions in different environments as well. So once you've got your suitable hypotheses identified, then you need to test those hypotheses. The framework provides some tailored integrated approaches to testing and assessment that take existing information or existing data, testing and modelling, combine them in an appropriate way to test that hypothesis in a very tailored way so that you're only gathering the information that you really require. These IATAs follow a format that has been suggested by the OECD. This is a rather complicated diagram that which you won't be able to read, but it shows you the complexity of an IATA that covers all potential hazard outcomes for an inhalation route of exposure. And this wouldn't be relevant for an individual hypothesis. Instead, what we do is we take our hypothesis. We have one in purple here, which is about high aspect ratio nanomaterials and tumour development, and another here which is about high aspect ratio materials and mesothelioma in orange. And you can see that we are able, or the framework is able to pick out the parts of the inhalation IATA which are relevant to that specific hypothesis, so that you can focus in on the questions that are most relevant to testing your hypothesis. So here we have a subsection of that inhalation IATA in this tailored IATA for a specific hypothesis. So these IATAs include questions and decision nodes. So the questions are in the blue boxes and the decision nodes are in black. And each of these questions and decision nodes are backed up by protocols or standard operating procedures that provide you with the methods you need to test those questions or to answer those questions. There are also thresholds or similarity values incorporated into each of these boxes that allow you to make a yes or a no decision for each question. So no would take you to the right and yes would take you down to the next question within the IATA. And there are a variety of exit points from the IATA as well. And these exit points are where you can make an evidence-based decision. And the evidence-based decision could be to consider a different route of exposure and a different hypothesis, or it could be that your hypothesis is justified and you have enough evidence to accept the hypothesis. So where are we now in terms of constructing the framework? Well, we're making a software blueprint that incorporates the basic information step, the existing hypothesis, the IATAs, and it links to a wiki which ensures we have uniform ontology across this project, which is also in line with the ontology used in other projects. The blueprint has been applied to make an online prototype software tool that's now ready to be tested. And we are using case studies within our own project to test the IATAs and the framework, and we're interested to work with stakeholders to test this with a wider variety of case studies. The software tool links to the gracious instance of eNanoMapper. So eNanoMapper is a database that contains much of the data generated by previous European projects and also from the OECD project. And so we can populate the data matrix within the gracious framework by linking to this eNanoMapper database. So the current status of the project is we have our hypotheses, we have our IATAs in a complete form. We're making the blueprint, which is machine readable, and it's also open access, which means anybody can get access to this blueprint. It integrates the hypotheses and the IATAs and the data sources, and the software is undergoing internal testing. We're also in the process of making a guidance document. We have a template under development, which we will populate with the information generated in the deliverables of the project, and it should be a stakeholder user-friendly guidance document. So now we'd like to invite our stakeholders to become involved in the project. We'd like you to test our IATAs. We'd like you to test our framework. You can look at the blueprint or you can look at the software version, and we'd like you to try and run your own case studies through the project, through the framework. So this is the front page of the software. You can see we have our gracious software and with links and information about the development. And then this is, once you've logged in, what you would see. So you'd see some information about your case study or the basic information, what they are, the life cycle, where they go, and then a grouping decision. And so the framework, the software leads you through the information requirements to allow you to generate your grouping decision. So this is what it would look like when you get to your grouping hypotheses. On the left-hand side, we have a list of potential hypotheses that are relevant to a particular nanoform, where POS in red shows that this hypothesis is accepted or it's positive, and orange MIS is missing. So these are hypotheses where we have missing information. On the right-hand side, you can see an IATA in green, where we have different tiers of information gathering and testing that can be fed into this framework in order to generate and gather the information to allow the hypothesis to be tested. So I'd like to finish there and thank you for listening to this broadcast today. And if you're interested in taking part in the testing of the IATAs or the framework, then please don't hesitate to contact me via my email address or the project via info@h2020gracious.eu. Thank you very much for listening.